What is electron configuration? Electron configuration. It is an atom that describes how the electrons are distributed among the orbitals. Quantum numbers. Number is principal quantum number. The second one is orbital angular momentum quantum number. And the third one is magnetic quantum number, and the last one is spin magnetic quantum number. The following table shows the possible number of electrons that can occupy each orbital in a given subshell. So there are three rules of electron configuration. The first one is alphabet principle, the second one is Pauli exclusion, and the third one is Hans rule. Pauli principle is a German word that means building up. This says that the electron fill the orbitals one at a time, starting with the lowest energy orbital, then proceeding to the one with the high energy. The order of occupation is as follows. The method is Madelung's rule. This order of occupation roughly represents the increasing energy level of the orbitals. Hence, electrons occupy the orbitals in such a way that the energy is kept at a minimum. Example number 1. Bromine atom, found in period 4, group 7 of the periodic table, have 35 electrons and 7 valence electrons. 4s orbital will be completely filled with 2 electrons, and the remaining 5 electrons will occupy the 4p orbital. The configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. Add the exponents and we will get a total of 35 electrons, confirming that our notation is correct. Hans rule. Atoms that ground states tend to have as many unpaired electrons as possible. When assigning electrons in orbitals, each electron will first fill all the orbitals with similar energy, before pairing with another electron in the half-filled orbital. When visualizing these processes, think about how electrons are exhibiting the same behavior as the same poles on a magnet would if they came into contact. Example number 2, oxygen and nitrogen. If we look at the correct electronic configuration of the nitrogen, X is equals to 7 atom, a very important element in the biology of plants. Oxygen has one more electron than nitrogen, and as the orbitals are all half-filled, the electron must pair up. Pauli exclusion. Pauli exclusion states that no two electrons can have the same 4 quantum numbers. The first 3 are L, N, and Ml, and may be the same, but the 4th quantum number must be different. One electron is spin up and the other would spin down. This tells us that each subshell has double the electrons per orbital. Example number 3, hydrogen and helium. We can conclude that these 4 quantum numbers refer to the 1s subshell. If only one of the ms values are given, then we would have the 1s1. If both are given, then we would have 1s2. Therefore, the 1s subshell can hold only 2 electrons, and when filled, the electrons have the opposite spins. Writing electron configurations. When writing an electron configuration, first write the energy level, then the subshell to be filled, and the superscript, which is the number of electrons in that subshell. Orbital diagrams is a visual aid to reconstruct the electron configuration by showing each of the separate orbitals and the spins on the electrons. This is done by first determining the subshell, then drawing each electron according to the stated rules above. Write the electron configuration for aluminum and indium. Aluminum is in the third period and it's an atomic number of 13. If you look at it in the periodic table, we can see that it is in P block. Now we should look at the orbitals that we filled in 1s, 2s, 2p, 3s, 3p. Now we should look at the orbitals that we filled 1s, 2s, 2p, 3s, 3p. We know that aluminum completely fills the 1s, 2s, 2p, and 3s orbitals because mathematically this would be 2 plus 2 plus 6 plus 2 equals 12. Note the following. Another example is indium. We now know that the electron configuration of indium is much longer than the aluminum. SPDF notation. Write the electronic configuration of yttrium. Start with a straightforward problem of finding the electron configuration of the element yttrium. As always, refer to the periodic table. The element yttrium is a transition metal found in the 5th period in group T. It has a total of 39 electrons. The electron configuration. This is much a simpler and more efficient way to portray electron configuration of an atom. Noble gas notation. In which the noble gas in the period above the element is being analyzed is used to denote the subshells that element is filled and after which the valence electrons are written. This is slightly different from SPDF notation as a reference noble gas must be indicated. Above example about the Afbal principle, it features in the group commonly known as the noble gases. The noble gases have the most stable electron configurations and are known as relatively inert. What is the electron configuration of vanadium? The electron configuration of vanadium. Thanks for watching.